provider, and we supply to financial organizations that host complex and technology advanced infrastructures such as London Stock Exchange Group or London Clearing House. Today I would like to discuss one of our projects of testing of a cloud-based risk management and post-trade system developed by one of our clients. During this presentation I will explain the top challenges that we had during this project and our ideas on how we try to overcome these challenges. So our client is a well-known software development company which builds software for different clearing houses and exchanges around the world, and they have a lot of experience of building software for clearing houses, and not long ago they decided to build their own system on cloud. It's software as a service. It's a risk management and post-trade system that they deliver to they try to deliver to banks and brokers. These are the main business requirements from the system. First of all, they have to support trade booking and position management cycle standard, and on top of that they should support various different features for their potential clients. Just to illustrate the size of the task that we had, these are all the instruments that we had to test. These are the types of instruments and markets where these instruments are traded. They decided to use cloud technology. They host the system in Amazon. There are three goals that they wanted to achieve by using cloud technology. First of all, they want to use elastic hardware allocation to support the real-time risk calculation algorithms. Second, they want to support a scalable platform that supports many different types of clients, banks and brokers. And third, they want to have the ability to quickly implement changes in this platform and changing the business rules without disrupting the platform itself. As the modern software development company, they're using Scrum as their software development process. They're not very religious about the Scrum, but they follow majority of the prescriptions of this methodology. We, as Exactpro, were invited by them to become an independent software vendor, independent software testing vendor for the system. And here are the three challenges that we identified in these projects. First of all, system complexity. From our experience, we know that risk management systems are complex stuff, but in this case, we have to support instruments traded on dozens of different exchanges. So it's the most complex risk management system that we've ever seen in our life. The second challenge was that we had to provide independent offshore testing team supporting the agile process. That was a challenge for us. And the third challenge was that we had to support various cloud-based cloud technologies. We have to adjust our services and tools to support cloud. So let's start with complexity. The risk management system has to process automatically the big volumes of diverse data sets. Also, they have to support complex nonlinear mathematical calculations. They have to maintain and row internal state of various positions that are in the system, and they have to support number of combinations of permutation of account structure and position portfolios. From our experience, the only answer to this challenge is to build automated end-to-end test library, regression test library that cover the testing of such complex system. And we have to use the tool complexity of which corresponds to the complexity of the risk management system that we are testing. In order to do this, we used our tool that we have developed by testing a number of clearinghouses, the tool called ClearTH. At the core of ClearTH is a test tool that's simulating external and internal interfaces of post-trade system and executes scripts in the form of CSV test matrices. The test matrix defines test steps and corresponding parameters, like this. Here is the example of the test matrix. It's very simple. Now have two major steps. First step is to send trade to the system, and the second step is to verify the resulting position. Here you can see the report of the execution of the test matrix. As you can see, the report contains all input parameters for the trade and all input parameters for verification and the results and comparison table between actual and expected result. So how can we build the end-to-end comprehensive end-to-end automated test library using this tool? First, we start with a simple test scenario. For example, we're submitting a single trade, and we verify position and verify account risk. Then we send update on behalf of market data system, then verify account risk again, and then we verify position after the date row, so the next day, the next business day. Now let's align this test case to the system business flow. On this step, we introduce global steps describing the system business processes and aligning our scenarios to the internal system scheduler. Now we can add other scenarios that implement other test cases, for example, testing other types of asset classes, etc., etc. After that, we can increase the coverage of different permutations by multiplying our scenarios. During this multiplication, our test tool takes one of the text matrices and replaces key test parameter of this test with different types of values. After that, we can start doing more complex tests. So in parallel with all of this, just to know that all these matrices in our test harness are executed in parallel and aligned with global steps within the system. So in parallel of all these matrices that we created, we can execute something that we call auxiliary matrix. This contains something that we call smart actions. These are actions that allow to test scenarios that couldn't be tested within isolated matrices, within the isolated test scenarios. For example, we need to test the algorithm that collects all positions and in the system and generate some aggregated report. So the verification of such aggregated report would be in this auxiliary test matrix. And in the end of all of this, we can add load to the system. We use our Woodpecker tool to generate advanced load against this system, and it also aligned with the global steps and with the system scheduler. So we generate load and we simulate outage at specific points. So by adding load to this functional testing library, we align ourselves to perform testing at the confluence of functional and non-functional tests and finding the complex defects that happen only under the load. So this is how we approach to building test library for our system. So the next challenge would be testing in Agile. This is the canonical approach to testing in Scrum team. You have to have a cross-functional Scrum team that does development, testing, and responsible for delivering shippable products at the end of the sprint. And this approach have various potential flaws in our opinion. First flaw, that developers has to test their code, and they have to use simplistic tools to do this. Usually these are unit tests, and they're lacking of independent view on the system when they're doing this. The second potential flaw is that since there is a strict deadline, you cannot move the deadline in the sprint, and the testing usually happens towards the end of the sprint when software is ready. You have to cut the corners in testing and deliver buggy software if you want to meet your deadline. And the third potential flaw is that in this case, no one looks at the system from end-to-end point of view, combining all the features delivered of different Scrums into one big picture and testing from end to end. On the other hand, if you are talking about independent test team, then we are talking about the waterfall model. There are BAs that prepare requirements, developers who implement the software, QA that tests the software and find the bugs, and it's going on and on. And in this case, this approach also has a lot of flaws, and the most well-known flaw is actually the time it takes to deliver some software to production is very lengthy comparing to the agile model. And our clients specifically ask us not to make them to work around using this model. But anyway, they wanted some independent testing. And this was our approach, how we did it. First of all, we embedded our agents into the Scrum teams, and they were just participating in all Scrum activities and testing the software as it was when it was ready by developers. And on the other hand, they extracted all important information from Scrum meetings, from project owners and discussions between project owners and developers, and feed them into a separate test Scrum team who was responsible for building end-to-end automated test library. And this team was working on building the test harness, test library, test scenarios, and providing these test matrices to other Scrum teams. And at the end of each sprint, the Scrum teams used this test harness to test the software. Actually, they can use it on a daily basis because at this particular moment, our test library consisting of several thousands of matrices can be executed within 5 hours, so they can run it daily on different versions of the system. So this is how we actually address the independent test team for Agile. And just to let you know that our independent test team is offshore, but we will manage to address this situation by using this scheme. And the last challenge that we had is cloud. Basically, when we started working with cloud, with Amazon Web Services, we had to adjust our test tools to implement several things. First of all, as usual, we're using REST API to connect to the system. This is a very common practice. On the other hand, in order to avoid significant internet traffic between our test tools and the cloud, we had to implement our test tools as Docker containers and run it within the Kubernetes to make sure that these test tools are near to the test system and can be tested from them. That's very important for load testing. And the third one, we have to integrate our test tools with Kubernetes in order to emulate various types of outages within the cloud. So this is the third challenge, and this is basically the end of my speech. So if you have any questions, please ask.
Any questions for Alexey? Yes, one in the corner.
If I understood correctly, you do a lot of non-functional testing and load testing, right? Mm-hmm. And you just mentioned at the end, they deploy the stuff to AWS, right? And now you don't know if the latency and so on just comes from the cloud provider, or you are just in a complete different data center. So actually every time you run the test suite, you might actually get complete different results just because it's not in your hands, it's not in your controlled environment. So how do you address this on AWS? Or
Basically, yes, it's not our controlled environment, but basically we, using Kubernetes, we see what's happening in AWS. When we see the actual structure of nodes and pods that was allocated to our system at any particular time, and we know what hardware is currently allocated for our system, this is so we can have some visibility on that. On another hand, we put our load test tools within the cloud, so we see it. So we emulate load from within the cloud. So basically, that's what we used to do. Yeah, we know that there is some random activity within the cloud may happen due to load. When the generate load system start adding more nodes and pods to the system, but we are able to test and monitor this activity and to see that latency can be controlled in this manner as well.
So your test tool is part of the Kubernetes cluster?
Yeah, we have to put it there because otherwise we had to produce all the load via the internet, which is not efficient.
Okay, I believe there was another question right at the front, if you don't mind waiting for the mic. So.
Hi, I am Ashok from Credit Suisse. So regarding the test Scrum, the setup that you mentioned, in principle it looks good, but there are two possible drawbacks which I could think, and how did you address it? The first thing is, okay, you get the information from Scrum teams and you feed to the test Scrum. So there are chances of some communication being lapsed, or when the transition is happening essentially. So first point, how do you address that? And from that setup, it looked like a one-way communication, that from Scrum team it goes to the test Scrum. But whatever the test Scrum is building, how do you feedback to the Scrum teams after the product is done? Because essentially you will be using that product into their Scrum teams. So how would you know that the product that you are building will be, or the automated solution that you are building is fit for purpose?
Yeah, first of all, we have this test Scrum team have own daily Scrum meetings, and all the agents are participating in this meeting. So after they have the meetings in their teams, they can participate in the test Scrum meeting and share this information as quickly as possible. And also the test owner of the Scrum team also participate in all other Scrums to be in loop. So that's how we try to address this. And regarding the delivery of the test solutions, basically currently it happens this, that all the teams that are working on different aspects of the system, they drop some intermediate drop to Amazon environment, and we run the test on daily basis and share the reports the tool generates, and involve the team to review this report and to see whether they're testing it correctly, incorrectly, etc., etc. And also we raise a lot of defects, and they have to look at these defects, etc. So that's how communication is done in this perspective.
Just one more question on that. Because we are adding one additional layer, that whatever a Scrum team will do and complete their activity. So what is the impact on velocity of the team? Because there is an additional layer of the work that needs to be done. So in percentage, have you seen like a traditional way it is a 10% drop or 5% drop? Because by how the communication protocol works, it has to add some lag to it. So any information on how much lag that adds to it?
Yeah, I don't think that we have really experience working without this scheme. We know that they have 3 weeks sprints, and we managed to fit into this 3-week sprint, even with this layer. But sometimes some defects are found after the sprint is found, but otherwise it's 3-week sprints.
Good. Do we have another question? Yes, the gentleman in the front, please.
So the main driver for this model was to have an independent test team that really pushed it. That's what really took it forward.
Yes, we have to. One of the main drivers we have to be independent test team. Yeah, and they asked specifically that they want independent test team to look at their platform.
So that's how I understood it, because you could have an enabling team that produce systems that help the teams. It's quite a common sort of model within sort of Scrum type models where you have a team that sets up automation to support the teams, but you're actually generating the tests that go into those teams. So it's the independence you do, because otherwise, I guess, as the gentleman was saying over there, why wouldn't you just federate the people into the teams, and then that test Scrum team doesn't need to exist? You could just say, well, you just join all those teams and they can now do what they need.
Unfortunately, the problem with this kind of management system that have to test end to end, and somebody have to look to the whole product rather than different streams, and that's why we have this end-to-end team to support this.
Thank you.
Okay, and the gentleman, final question.
If you don't mind.
Yeah, do you mind just standing for the mic? Thank you.
So I think I've understood what you said. So you've got an external team that effectively performs testing within a squad or a scrum, and then also conducts the testing independently as part of the end-to-end function. Is that right?
Yes.
Yeah. So how do you resolve the issues of co-location? So I work in an agile environment. I'm a big advocate for co-location. So our squad teams or our scrum teams or sprint teams, they're all in one location. They have cross capability. So a tester can probably do a tiny bit of dev, or might be able to unit test, and the devs might be able to cover for testing, and vice versa. So how do you resolve those sorts of challenges?
In this project, it was already not really co-located because in this situation, the development team was in one remote location, and the BAs, or project owners, were in London, so they were scrummed over the Skype for Business.
So they would do that.
Yeah, and so we just added to the Skype for Business conferences and using this. And on top of that, these agents, as we call them, they are quite often on site. So they spend 30 to 40% of the time on site with developers. So that's how we try to solve this. And the beginning of the sprint and the end of the sprint, we have test owner on site with developers and BAs, so they can connect. They gather together in one location.
Okay, I probably have 100 other questions, so I won't ask because we'll probably run out of time. So I'm going to stop here. Thank you for that.
Thank you very much.
Okay, well, Alexey, thank you very much indeed.
Thank you.